We shall have a look at the definite integral, and the definite integral is defined between two numerical values of x which are called limits. One is the lower value is called the lower limit, and the upper value is called the upper limit. It only happens if the integral is defined as continuous between the values of a and b. So mathematically it kind of notation goes something like that's the lower limit, that's the upper limit of f of x with respect to x, and a and b are x values, or with respect to values. If there is r, then a and b will be r, is equal to capital F of x, and we put square brackets and we put the limits, and if we substitute a and b, so we get f of, we do b first, minus f of a, and so that is what the definite integral is all about. Okay, now one of the important things to note here is that if you differentiate f with respect to x, you will get f, and well, or f dash would be equal to small f. Right, you have to note that in a definite integral there is no constant of integration. There's no c, because you have got a value at the end, so therefore there's no c. The second thing you gotta note is the limits. A and b are values of x. X if the integral is with respect to, let's say, whatever it is, with respect to dx. So if it is dx, then a and b are values of x. Alright, let's do some examples. So the first example, we get to evaluate from negative 2 to 2 of a function that is given. Now there's two brackets, we've all got x's in there, so we can just expand and then integrate. So if you expand, so you will go, that's a perfect square, 2x square minus 1 whole thing square, and then multiply by x, you'll end up with 4, so you end up with from negative 2 to 2, 4x to the power 5 minus 4x cubed plus x with respect to x. So I did a shortcut here, but you can do the expansion any way that you like. And if anyone has any issues with expanding a perfect square, let me know. So what we do is we use open square brackets and we integrate. So this will become 4x to the power 6 over 6 minus 4x to the power 4 over 4 plus x squared over 2 from negative 2 to 2. 2. So I would simplify it before I proceed. So 4 over 6 would be 2 over 3 x to the power 6 minus 4 will cancel with 4 at the bottom, x to the power 4 plus x squared over 2 from minus 2 to 2. So I will substitute 2. So 2/3 2 to the power 6 minus 2 to the power 4 plus 2 to the power 2 over 2 minus negative 2/3 negative 2 to the power 6 minus minus 2 to the power 4, oops, sorry, plus minus 2 to the power 2 over 2. So if you plug that all in the calculator, sorry, you end up with 0. The value you get for here would be exactly the same as here, and then you minus them, you end up with 0. So that is the definite integral. Cool, let's do some more. Okay, so let's evaluate 5 to 10, 3 over square root of x minus 1. So you've got like a sorry, so you've got square root of x minus 1 at the bottom, which you can put to a rational power, whole thing x minus 1 whole thing to the power half. Take it up, it becomes 3, so it'll be 5 to 10, 3 bracket x minus 1 to the power negative half dot dx. You can take out the 3 and put it outside. So that gives you from 5 to 10, 3 goes out, and x minus 1 to the power negative half dot dx. And if you substitute, well, actually, if you integrate, sorry, you can leave the 3 outside. You get x minus 1 to the power half. Minus half plus 1 is positive half. And it goes from 5 to 10. I can put the set back on if you want, which will give you 3 into square root of x minus 1 from 5 to 10. Let's substitute. So you got 3 square root of 10 minus 1 minus square root of 5 minus 1. Actually, you don't have to put square here, which gives you 3 into square root of 9 minus square root of, well, that's pretty straightforward, right? 9 minus square root of 4, which gives you 3 into 3 minus 2, which gives you 3. And that is your definite integral for, cool, just give me a sec. Okay, I missed something. When you have this half here, and when you integrate, that half would be, you divide by half, so half, and that 2 will come up here, and therefore it'll be 2 and 2, and there'll be 2 and 2, so that will be, sorry, I'll erase that. That will end up with, see, that's called a silly mistake, and so there will be 3 into 6 minus 2 times 2, 4, which will give you 2 times 3, which actually gives you 6. All right, let's do some more. All right, so let's find the integral of negative 1 to 2 of cx plus d dot dx, where c and d are constants. Let's go through the process, what we come up with. So that's negative 1 to 2 cx plus d dot dx would be equal to cx squared over 2 plus dx, and it goes from minus 1 to 2. So that will give you c times 2 squared over 2 plus d times 2 minus c times negative 1 squared over 2 plus negative, d times negative 1. So what I'm doing is I'm substituting the upper limit here in place of x and the lower limit in place of x over here. So if I simplify this here, I get 2 to 4 divided by 2 as 2c plus 2d minus negative 1 squared be half, so c over 2 minus D. So if I open the brackets, I get 2C plus 2D minus C over 2 plus D. So if you combine the 2C and minus, so 2C minus half C would be 1.5C or 3C over 2, and 2D plus D is plus 3D, and there you go. So if you have any values of C and D, you can just use them the way they are in this scenario. And for example, if C is 5 and D is 10, all you do is substitute and you get your sorry, you get a solution. You get your definite integral. All right, let's move on. Let's have a look at area. So the area between a curve and the x-axis. So let's say x-axis, and that's your curve. Sorry, my curve is going a little weird. But yeah, the area between them is that area, and two vertical lines because that's what A and B are, is given by the definite integral of f of x between the lower and the upper limits, which is A and B. Meaning if you take the definite integral AB fx dot dx, you get area. So let's do an example and see how that actually works. So let's find the area bound by the curve. It's a quadratic, x squared minus 2x plus 4, and the x-axis, and the vertical lines x equals 1 and x equals 3. So the area goes kind of between there, and there, all that. So if we use the formula, we put the lower limit and the upper limit, and the function dot dx, and so we integrate. Square bracket x3 over 3 minus 2x2 over 2 plus 4x, going from 1 to 3. Oops. 3. So if I simplify, I get x cubed over 3 minus x squared plus 4x, all the way from 1 to 3. Let's substitute the value of 3 in x cubed over 3, so you get 3 cubed over 3 minus 3 squared plus 4 times 3 minus 1 cubed would be 1 over 3 minus 1 squared plus 4 times 1. And if you substitute the values, you end up with 8 and 2/3. So you can clearly see that this is the x-axis, and so the area is in the first quadrant, therefore it's positive area, and the value you get is positive. So pretty much looking all good. Let's have a look at some. So if we have a look at y equals x cubed, a cubic, and we want to find the area between x equals -2 and 2, the shaded area that is given here, as you can see. So if we just apply the formula directly, we get area is equal to -2 to 2 of x cubed dot dx. So we end up with x to the power of 4 over 4, going from -2 to 2. So if you substitute 2, you get 2 to the power of 4 over 4 minus -2 to the power of 4 over 4. And this will give you 4 minus 4, area 0. So area obviously cannot be 0, because you can clearly see there's area here and there's area here. Now what has happened is the value of the area on the first quadrant is +4, and the value of the area in the third quadrant is -4. Therefore, when you add them up, they look like sunglasses. Well, when you add them up, you end up with 0. So what can we do with this scenario like this? Let's have a look. So what we do is when we have area below the x-axis, like that one here, we separate the limits from, it goes from -2 to 0 and then 0 to 2, and we find the area separately. So since we know the area from -2 to 0 would be negative, we find the modulus or the absolute value of the area from -2 to 2 x cubed dot dx and add it to the area of 0 to 2 x cubed dot dx. And therefore, when we integrate, we end up with x to the power 4 over 4 square bracket is inside the absolute value sign from -2 to 0 plus x 4 over 4 0 to 2. We will end up with absolute value of -4 plus 4, and therefore 4 plus 4, which will give us 8 square units or whatever it is. 8 as the area as 8 as the area. Therefore, you can see if we had just found the definite integral starting from -2 to 2, we will end up with 0. And we can't do that straight away. So if we are finding area, which is one of the applications of definite integrals, we have to sort of, graphs would be given, and you have to figure out the limit sometimes, but you'll be given the limit sometimes, and then you have to break them down and find the absolute value of the negative area, or the negative, not area, negative definite integral, and then add them up. So make sure they are all positive before you add them up, and you get the total area. Okay, cool. Let's have a look at area between curves. So let's say you've got two functions. One of the functions is, let's say, g of x. So, sorry, y is equal to g of x, which is that function, and y equals f of x, which is the other function. And therefore, if you want to find the envelope or the area between them, all we do is we find the points of intersect, find the points of intersect, in this instance x1 and x2, and so the area between them is always x1, x2. F of x minus g of x dot dx. Now, f of x, as you can see, is the upper envelope of the curve. So the curve on top minus the curve at the bottom. So the area of the curve at the top minus the area of the curve at the bottom. And this works no matter if the area is positive or negative or what. So let's do an example and see how it works. All right, let's do an example on find the shaded area between a parabola and a straight line. So the equation of the straight line is y equals x, or y equals 1x plus 0 if you want, and the parabola is y equals x squared minus x, or y equals x into x minus 1. Right, so first of all, you have to make sure that you know how to find the interval of the definite integral. So one of them is, you can clearly see that they intersect at 0, 0, which is easy, fine. The other one is if they intersect at well, a point, which we don't know. They intersect at the curve and the straight line, wherever the intersect is, can be found by using simultaneous equations. So you have y equals something, you have y equals something. If you combine them, or if you equate them together, we end up with x2, or the upper limit. So if you go x is equal to x into x minus 1. Sorry. Sorry. Then you can expand the right hand side, which is, oops, sorry, what's going on here? So you go, sorry. You go x equals x squared minus x. And which will, if you take this x to the right hand side, you get 0 equals x squared minus x minus x, which will give you 0 equals x squared minus 2x. So sorry, if you factorize this, you end up with x into x minus 2 equals 0. Therefore the solution to this is 0 and 2. If you have a graphics calculator, you can just solve it straight away and get the answer, but you can see clearly that one of the intersect is 0, which is there, and the other one would be, so I can relabel this now as 2. So you have found your upper and lower limits. All right, so let's do the calculation of the area. All right, so if you write down the notation for area, so so the upper function is x equals y, and the lower function is x squared minus x. I just expanded the y equals x into x minus 1, and if you substitute them in here, you end up with 0 to 2 of x minus x squared plus x dot dx, and these will add up, so you end up with 0 to 2 of 2x minus x square dot dx. So this is what you have to actually find the definite integral to get the area. So you will end up with 2x squared over 2 minus x3 over 3 going from 0 to 2. If you simplify, you end up with x squared minus x3 over 3 going from 0 to 2. And if you substitute, we go 2 squared minus 2 cubed over 3 minus 0, because if you substitute 0 in place of x, you will end up with 0. And therefore you get 4 minus 2 to 4 is 8 over 3 over 3, which will give you 4 over 3. And that is the area between the two curves. All right, there you go.